So after calculus, we can also talk about linear algebra, which would be quite an important LaTeX tech to learn for those who are in 16AB. Once again, create a linear algebra folder, which might be hidden in here. Sometimes it does that. Alright, I'm going to name my file now, just for abbreviations. And I'm also going to put an input comment here, so that I can continue off what I had last time. Okay, here we go. So, section title, linear algebra. A couple of things I'd like to go through linear algebra are mainly the mathematical objects in linear algebra that you will encounter in 16AB. For example, vectors and matrices and augmented matrices, which all of which have very interesting ways to write out, and some of them will have some customized environment to do. Okay, we went through vectors in the last video, but I'll go through it again. If you want to put an arrow mark on something, you can just use \vec. Now, alternatively, you can also use a bracket notation for a vector, but I don't think that's the mainstream notation in 16AB. It is the mainstream notation for some professors in Math 53, so it'll also be a good thing to learn on your own. Okay, now that we have talked about vectors, we can also talk about norm. To express the norm of your vector, the simpler way of doing that is to write \lvert and \rvert and put your vector within the space between these verts. For example, this. So the might be blocking it a little. Am I blocking it? I'm probably not blocking it. Okay, so here's how you can write norms, which, as you can see, \over \rvert. Now, if we're going to write larger vector notations in terms of size, for example, maybe my vector is within a fraction, then you will see that this \over it is not quite big enough to contain it. So I'll use the \left and \right command, which helps me make the norm bigger. Yes, I'm not blocking the vector. Okay. So these are how you write norms for vectors. Now we can talk about matrices, which we have not talked about yet. To write a matrix, the environment you can use is called begin B matrix. So in here, just like in a tabular environment as talked about in the first tutorial video, you align elements using AND and switch line using line breaks. And once again, subscripts that have multiple characters should be embraced by a curly bracket. So here's what you will see for a matrix. Now we can also make the inverse of a matrix, and it will follow a quite simple procedure, which is just adding a superscript of -1 to it. Same for here. So as you can see, this is an inverse matrix, and this is a inverse matrix, but directly written for the matrix notation you see here in rectangular array. Transpose follows a similar logic, so I'll not go through it. Now you can also write an array, which is a matrix version of a line. Okay, here's an interesting LaTeX tech, which is that if you write double quotation mark in its original form like this, some compilers might not be able to notice them, which is why I currently use the tick and then quote notation for double quotation mark. Okay, so as spoken before, this array environment is the matrix version of a line, as we talked about before. What I mean by that is I can use an array, close it, and I can align elements in here just like it's in a tabular. For example, I can type text here. And I can line break as usual in the B, just like in the B matrix. And I can also write out elements. So in that case, B matrix is also kind of like a line, but it also has a bracket notation around, so it's not like an line. Well, now in array, you don't have brackets around it, so you can freely treat this as basically a table or a multi-align star environment where you can write a lot of equations in. But mostly arrays are used for tables or sets of vectors in our content so far. So if you want to write a lot of equation, I'll still recommend you use the align star environment. We can make a comparison between these two environments later. But for now, this is how an array environment looks like. There are some errors because we forgot to add in arguments here. So just like how tabulars have different letters like C here, array also has letters here to determine the structure of this overall array. After all, it's a rectangular array within a rectangle structure, so we would like to know how many, the computer would like to know how many columns does your array plan to have. In this case, if you write L here, it means left aligned content. C is center content and right is right aligned content. Let's see the difference. Very interesting. You can also put a vertical bar here. So we have a augmented matrix here, basically. Now let's see if you can do the same thing in B matrix. No, you cannot. Which is why array is also useful for augmented matrix. But for augmented matrix, there is a Stack Overflow way to write it, which I currently have put in the CSM library so far. And this Stack Overflow solution works for an overall Gaussian elimination. I did some micro tuning after the Stack Overflow solution, but let me try to pick that out from my overleaf. This is the main document that I will release afterwards. Okay, here's another interlude. As you can see, I'm using this document from another device, so you can see my name up here. If your teammate is using the same document or the same project as you are, you might be able to see their name initial here. And I also don't have a profile picture on overleaf so far, which is why it's showing a letter. I should work on that later. But here's a sys matrix environment that I micro-tuned from Stack Overflow, which I'll put in main.tech because we should put environments in front of the begin document sign. And I'll try to demonstrate to you how this sys matrix thing works out with an excerpt from our previous guide. I'm going to copy paste this section to show you what is going on with this new solution of Gaussian elimination that we have here. So let me try to launch this. Oh, hold on a bit. The array is not doing what it should again. I wonder if I pasted something weird. In this case, you can also go look at the log to debug the file, which I totally did not expect to happen because this did not happen in the test run. I am in trouble. So it already has an error. Oh, right, that's because I accidentally deleted the LCR here. Okay, that is pretty weird. Once again, LCR means the way in which you will align your contents in a column. And each letter means one column. Okay. There's also a 2cm box here that shows up as an error because this Stack Overflow solution requires some more packages to use. Once again, packages will be taken care of by your course file, so do not worry too much about it. The package we're missing here should be math tools. Yeah. Okay, so this is our current solution, Stack Overflow solution for Gaussian elimination. Whereas you can see this sys matrix here is very similar to how an array is written, and we can also use \RO as a shorthand comment for row operation. Okay, so that's all I have for linear algebra. The linear algebra sections for 16AP is really mostly about being able to use the calculus notation and being able to use matrix notations. Once you're very familiar with environments like B matrix, then you should be set to go for the linear algebra section.